Alright, good morning guys and welcome to today's class. Today we are going to be doing organic chemistry, IUPAC nomenclature of organic compounds, and I would love you guys to follow me on this journey. Very interesting questions, 7 organic compounds we want to quickly name. You can bring down your jotter and your pen and jot down some relevant points on organic chemistry. Now look at the first compound here. I'll be giving some rules. I'll be focusing on number 1. Now look at CHO is what I'm seeing here. CHO, which is alkanoates under carbohydrate, alkanoates. So it means this whole compound is an alkanal. Now the first thing now is, remember the rule that says, let me open my marker, carbonic carbon is carbon number 1. So this is carbon 1, carbon 2, carbon 3, carbon 4. So this is 4. 4 is but. I will get it now. This is butanol. Now I'm having OH on the third carbon atom. Remember that is carbon 1, carbon 2, carbon 3. So therefore, the IUPAC for number 1 is 3-hydroxybutanol. That is just that. You can engage me in the comment section if you are lost. This is 3-hydroxybutanol. That means on the third carbon atom, I have hydroxy. Now let's go to number 2. Remember the rule again. Carbonic carbon is carbon number 1. When we talk about carbon, that is carbon and oxygen. So this is carbon 1, 1, 2. This is just H. Now I have C2H5. This is alkyl. Normally ethane is C2H6. But when you remove one hydrogen atom from alkane, it gives you alkyl. So this is alkyl. So I have alkyl, I have ethanoate. This is COO. I call it RICO. COO is under alkanoates. I'll get now. This is 1, 2. This is ethanoate. So the IUPAC nomenclature for number 2 is ethyl ethanoate. Ethyl ethanoate. These are esters. Esters, they have the CO functional group. I call it RICO minus. This is how we symbolize it. Now for number 3, which is kind of like a lengthy one. Look at this number 3. If you look at number 3 too, you are still having carbonic carbon. This is 1, 2, 3, 4. Now let me make a statement. You have COOH to be alkanoic. When the hydroxyl of carboxylic is replaced with amino, it gives you an amide. The statement seems kind of controversial or not really, I don't really know how to put it. When the hydroxyl of carboxylic is replaced with amide, it gives you an amide. So this compound here, 1, 2, 3, 4, this is an amide, Now I want to give the IUPAC nomenclature for number 3. You can see it in questions, WAEC, NECO, or JAM. So this is 1, 2, 3. On the third carbon atom, I have methyl. This is methyl, CH3. I have methyl on the third carbon atom. So this is 3-methyl. 1, 2, 3, 4. Butanamide. Let me write it for us to see it. This is 3-methyl butanamide. Butanamide. 3-methyl butanamide. What I'm doing this morning basically is not to give you guys fish, but to teach you guys how to catch the fish. I've explained the amide is CH3 by now. It's very easy for us to know that CH3 is methyl. Like I said initially, CH4 is methane. But when you remove one hydrogen atom from alkane, it gives you alkyl. So CH3 is methyl. I'll get now under the alkyl. This one is under the alkyl group. The alkyl is CnH2n plus 1. Now for number 4, very straightforward. This is just ethane dioic acid. This is ethane dioic. That is how I write this, ethane dioic. You have 2 alkanoic acid together, 1, 2, 8. I have always given the scope. 1 is Meth, 2, 8, 3, prop, 4, boot, 5, Pent, 6, X, 7, Hept, 8, Oct, 9, None, and 10, Dec. Let me just give you guys a very short quote. Eicosane, the most complex alkane, that one is C20-IR. Methane is the simplest alkane. Now let's go back to number 5. This is benzene. Benzene has a ring-like structure. ClCl. This is para-dichlorobenzene. Parallel to each other. Para-dichlorobenzene. But remember that if you have something like this and there's no ring inside, it's no longer benzene. This one is cyclohexane. But remember, sometimes the ring like can be in this form like this. It can be in this form like this. Now let's go to number 6. You can see it again. CHO, alkanal. Now this is 1, 2, 3, 4, butanol. It's similar to number 3. Very similar but different. See, no, not number three rather. I think number one rather, yeah. Number one, similar to number one. Now let's look at number six together. This is 3 hydroxy 1 2 3 4. This is 3 hydroxy butanol. Are they not the same thing? They're actually the same thing, sir. Sorry for that. Probably I made a mistake in the writing. They're actually the same thing, but no problem. We give the IPAC in easier form. I think it was supposed to be the one I was checking. It's supposed to be pentanol. Probably it was. So we can just keep this number 6 in asterisks. I think it's supposed to be 3 hydroxypentanol. There was a mix up here. Butane. Let's do this together. Butane, Cn, H2n plus 2 for the alkane. So that would be C4, 2 times 4, 8, 10. C4 is 10. 1, 2, 3, 4. This is 3, 4, 5, 6, 7, 8. Yeah, it's complete. Yeah, it's actually complete. Now let's go to number 7. Number 7, you have RICO, COO. Remember, COO is different from COA. This CH3 will be treated separately. So this is carbon number 1. Following the rule that says carbonic carbon is carbon number 1. So this is 1, 2, 3, 4. 4 is but. So this is methyl. This is now methyl butanoate. Straight up. The name for this is methyl. Then I take this one 1, 2, 3, 4. This is butanoate because of COO, alkanoate. So it becomes methyl butanoate. Your questions are welcome. We can look at it together and engage me. I'll be very, very active in the comment section. If there are any controversial or any aspect you're actually skeptical, I remain your tutor, Atilola Peter. You can subscribe to my YouTube channel at Peter Atilola. Thank you very much. Have a wonderful morning.